Greetings. My name is Kale Karis and I'm a reggae artist. I say that to say, generally this is not the type of content that I create. I usually create content related to my music, lifestyle, travel, etc. However, earlier this year I created a generator enclosure. You can see it behind me here. That has garnished a lot of attention. I got a lot of views, many comments, probably tripled my followers. And so to the people who are following me based on that video, thank you. I know it's not my general content. So I was asked to come on and do a follow-up video, lessons learned. You know, some people have made some comment of some things that I should have done differently. I'm going to address some of that. Before I go into that, I want to advise you guys to make sure that you stick to your county code. My stuff is inspected, contrary to what some of the people have been saying on here. I went through building inspection and get all my stuff, follow the codes, get all my stuff inspected. I've made some changes based on the comment, regardless if I passed or not. I've made some minor changes to some of the stuff, so I'll address that also. Let me see if there's anything I want to address before I go into it. But yeah, I'm just going to go through the comment, answer the questions, and then we're going to push forward. So I decided to come inside and do a voiceover because my neighbor's dog, every time it heard my voice, it just kept barking. So I think it's more practical for me to come inside and just do a voiceover to the video. Here we go. The first question I'm going to answer comes from someone who lives in Florida, which also happens to be my state. This individual wants to know whether a permit is required for installing the interlock switch, inlet box, and other outdoor electrical work. The simple answer is yes. In my situation, I didn't need a separate permit for the interlock switch or outlet box. It was all included under the main electrical permit, so there was only one fee for that. However, because the enclosure is considered a permanent structure, it required its own permit. One of the most commonly asked questions in my comments is about accessing the generator to perform an oil change. And this situation taught me two important lessons. First is that I should have installed a larger enclosure. Unfortunately, I didn't have the freedom to do so because the distance between the fence and the enclosure is limited. According to code, there must be sufficient space between the enclosure and the fence, and a larger unit would have violated that requirement. I was also asked about removing the generator for maintenance without having to remove the side panel. Personally, I don't have that requirement because my generator is bolted directly to the concrete pad. What I did was place a piece of concrete board on the bottom of the enclosure and bolt the board to the concrete pad, right here. This reinforces the enclosure, especially since this metal box has a plastic bottom that the side panel screws into. You cannot see it in this video, but I also drilled a few drainage holes in the plastic just in case some water gets inside. From there, I bolted the generator to the concrete pad to keep it firmly in place. With that said, if I were to take on the task of making the generator removable without taking off the side panel, I would first remove the entire side panel and reinforce the back of it so that it's not flimsy, and then mount the side panels using hinges. Creating a swing outdoor. The only consideration would be ensuring you have enough space for the door to swing open freely. Only lingering problem I've encountered with this design is that the connection between the generator exhaust and the exhaust pipe kept coming apart because the screws would work their way out from vibration. When this happened, the enclosure would fill with carbon monoxide, causing the generator to shut off. I fixed this problem by replacing the two Phillips head screws with hex head bolts and using a torque wrench to tighten them properly. This ensured a secure connection, something I wasn't able to achieve by hand. Another question raised was about vibration. They were asking whether I took steps to prepare for or address the vibration and oscillation that a generator naturally produces, specifically in regards to the exhaust system. Initially, vibration was a concern for me, which is why I designed the system to use flexible exhaust piping. However, I had difficulty finding the right combination of length and diameter. So I reverted to using black iron piping, which I already had on hand. Additionally, the galvanized sheeting used on the enclosure is thin enough to allow a bit of flex. So the vibration transfer from the pipe to the side panel, which ultimately helps alleviate that concern. Another modification I made to improve airflow and help remove carbon monoxide from the enclosure was installing an air intake fan. I consider this lesson learned number 3. Since this wasn't part of the original design, I could not go back and install a full-size fan like the one used on the exhaust side because of space limitations. Instead, I purchased a small, inexpensive fan from Amazon and positioned it between the existing intake vent and the generator. It works exactly as intended. If you decide to build your own generator enclosure, I'd recommend installing an intake fan as well. It doesn't need to be as large as the exhaust fan, but having one will definitely help improve airflow and safety. I received some constructive feedback in the comments from a couple of viewers whom I believe are licensed electricians, or at least know more about this type of work than I do. They pointed out that I cannot run Romex through outdoor conduit in an outdoor environment. This brings me to lesson learned number 4. First, I will show you how I incorrectly ran the wires for the 2 electrical circuit. Then I'll share what I've learned and how I recommend doing it now that I have a better understanding, especially if you're planning on taking on this task yourself. As you will see, I haven't corrected my mistake yet. I've ordered the parts and plan to make my changes when I install the rear access panel. Since this topic was new to me, I figure other beginners might appreciate a simple explanation of Romex versus individual conductors. Feel free to skip ahead if this topic is of no interest to you. For anyone not familiar with the term Romex, it is a type of electrical cable commonly used inside houses. It contains multiple wires bonded together inside one protective jacket. It's designed for dry indoor locations only, not for damp or wet areas. Romex is actually a brand name. The correct term is non-metallic cable. Individual conductors, on the other hand, are single wires that must run inside a conduit, a protective pipe. When installed in the correct type of conduit, these conductors can be used in damp or wet locations, such as outdoor, garages, or other areas with moisture, depending on their rating. First, I'll show exactly how I ran the wires for the 2 electrical circuits. In this setup, I have 2 circuits: the generator output going to the house and the commercial power entering the enclosure. Both circuits, from the point where they leave the enclosure to the house, were done correctly, meaning there are no jackets on the wires running through the flex or PVC conduits. The issue is that I did not properly transition from the non-metallic cable to the individual conductors. Instead, I left portions of the jackets on the ends of the wires because I didn't want the individual conductors to be exposed. Then pushed the jacketed section about 1.5 inches into the flexible conduit. This is why it appears as though Romex was run inside the conduits. To be clear, there is no outer jacket between the enclosure and the inlet box. Similarly, there is no outer jacket leaving the inlet box and entering the house, as you can see here. That brings me to lesson learned number 4. Use terminal blocks to properly transition between non-metallic cable and individual conductors for both the 15 amp circuit and the 60 amp circuit. Now, this is how I plan to fix the error. I purchased 2 terminal blocks, one for each circuit, a 3-position block for the 15 amp circuit and a 4-position block for the 60 amp circuit. When time permits, I'll install both blocks by mounting them on the cement board somewhere around here. Strip back the non-metallic cable and connect those conductors to one side of each terminal block. Then connect the individual conductors currently in the flexible conduit to the other side, as shown in the illustrations. If anyone has a better recommendation, please share it in the comments. I still have time before I perform this modification. It was also pointed out that GFCI protection is required for this installation. I didn't show this in the previous video, but on the opposite side of this wall there's another outlet that provides weather protection. This is the circuit coming from the house that supplies utility power to the components inside the generator enclosure. I covered this setup in the original video, so if you haven't seen that one, you can check it out and see how everything is arranged. From my understanding of the code, the GFCI outlet must be the closest one to the breaker panel, which is the one inside the garage. In my setup, the outlet inside the enclosure does not need to be GFCI. Electricians, please let me know if this interpretation is correct. Several viewers pointed out that the automatic transfer switch inside the enclosure may not be necessary. They are 100% correct, and this is something that I overlooked. Since the generator will power the entire home when it's running, it will naturally send power back to the enclosure to operate the fan and other sensors. In other words, the transfer switch isn't needed in this setup, so you can save some money and skip installing it. I received several comments regarding grounding. As you saw in my previous video, I grounded the generator using a grounding rod. After doing some research to better understand the proper approach and considering the recommendations I received, I realized the fix was actually very simple. Disconnect the generator from the grounding rod. The generator was already grounded to the breaker panel, so the additional rod was unnecessary. Lesson learned number 5 is that you don't need a separate grounding rod when the generator is bonded to the home's electrical system, because the breaker panel already provides a proper grounding path through the grounding electrode system. Adding another grounding rod can actually create ground potential differences, which may introduce safety issues rather than solve them. In short, once the generator is tied into the home's electrical system, it shares the same ground, so no additional rod is needed. Now let's discuss the topic everyone has been asking about, the noise test. I've received a lot of questions and requests regarding the sound level. First, let me say generator noise isn't a concern for me, mainly because several of my neighbors have generators and I'm certain theirs are louder than mine. Personally, I don't notice much difference between the enclosure being closed and the lid being open. So, if noise is a concern for you, I recommend adding soundproofing to your enclosure to help reduce the level even further. Nonetheless, let's run a noise test. I'm standing about 5 feet away from the enclosure. First, I will start the generator with the enclosure lid closed and take a measurement. Then I'll open the lid and take another measurement to compare the difference. Here we go. I use the maximum button because it works as a hold feature that locks in the highest noise level. Without it, the reading would constantly fluctuate and be difficult to capture accurately. Now listen for the change in noise level as I open the enclosure lid. As you can tell, there isn't much of a difference. We measured 94.4 dB with the lid closed and 95.4 dB with the lid open, a difference of only 1 dB. In my opinion, a 1 dB difference is insignificant. So to reiterate, if noise is a concern for you, you will need to soundproof the enclosure. There you have it, folks. Thank you all for watching. If you have any questions, please leave them in the comments or send me a message on Instagram. People have reached out to me before and have shared their designs. I'd love to see yours too.